All right, so let's start the next package. And the next package, and again this is a quick introduction for those packages, and if you want to see further functionalities of these packages, you can always go through the help files of these packages, right? Next package is the Pandas package, right? This is a short for panel data, right? So it's a very useful package, particularly for data that is arranged in tabular format, right? For instance, you have something like, you have, let's say, this is sort of the table that you have, right? And then in the table you have these rows, and then you have these columns, right? So you have this entire thing, you can load it as a data frame in Pandas. And what is a series in Pandas? A series in Pandas is essentially each one of these columns. So you can load tabular data in the form of a data frame in Pandas library, right? And if you have just columns, you can load them or you can process them as series data. Does that make sense so far? Yeah, so again we are discussing the Pandas library. It stands for panel data, right? Library. And why is it useful, or what is it used for? We primarily use it for data that are arranged in tabular format. Okay. So how do we import Pandas? We can import Pandas by saying import Pandas. That's it, right? Pandas is a very long name. So like for example NumPy, we said import NumPy as NP. Similarly, we can say import Pandas as PD, right? Because PD is generally more commonly, it's a convention. You don't have to call it PD. You can call it whatever you want to call it, right? You can call it CD, right? Or you can call it DD as you want. Questions so far? All good? Yeah. Okay. So what else? Okay. We say import Pandas as PD, and let's make a data frame, right? We say df equals PD dot data frame, right? And in the parentheses we provide a dictionary. So in the dictionary we have, let's say, the key's name, and let's say this is a list of, let's say, Usman, Ali, Ahmed, Fatima, right, Aisha, right, Ania, right, and so on and so forth. This is, let's say, one of these entries. And then we have, let's say, age. Have another key which is the age of these people, right? And let's say the age I write as 20. Then we have 15. Then we have 76. Then we have 21, right? So what do we, how many entries we have? 1 2 3 4 5 6. So 1 2 3 4. Let's have two more, 12 and 30, right? We have the age, and we have, let's say, sex. So let's say we have male. Again we have male, So 1, 2, 3, 3 males, and we have 3 females. Right. So this is a dictionary that contains 3 keys: name, age, and sex. Right. You want to have more keys, you can have more keys, no problem. Right. But then I'm converting this dictionary into a data frame, and then for example here I say print df. It gave me a problem. Why? Because in this data frame this f is in caps. I say print, yeah. So now you can see it converted this dictionary into a data frame. It has these columns: name, age, and sex, right? So the keys that you had here became the titles of the columns, and then you have these indices 0, 1, 2, 3, 4, 5, right? And for each one of these indices you have all these guys. So Usman 20 and male, so that was in one line, so for that reason it became in one row, right? Similarly Ali 15 and male, they were corresponding, so that is why they became one row, and so on and so forth. Clear? Any questions till this point? All good? So what we did, we created a data frame with some user defined data. Now you can have interesting functions, like for example data frame has a function known as describe function, right? So if I just want to describe my data frame, I can run this function, and that function will operate on the numerical column of my data. So here you see the numerical column is age, right? So it is trying to describe that numerical column. What it's telling me, that there are 6 values. The mean is 29, the standard deviation is this, the minimum value is this, and these are quartiles. If you don't understand them for now, that's fine, we will have a look at them later, and the maximum value is 76. Clear? Any questions to this point? Okay. And if you wanted, you can just hide this dictionary separately. This dictionary, for example, you say sum underscore data equal to this, and then can say sum underscore data equal to this. So you can have this dictionary defined separately as well, but this, when you call the data frame, it's just going to convert the dictionary into a data frame. Okay. Now we discussed a data frame. What about series? If you just have columns, you can use series for that. For example, if I have, let's say, ages equal pd dot series, and I say the list 12, 13, 23, 67, 89, 100, right? And then I can have, let's say, a name equals, let's say, age, right? And I can just say print ages. It's going to just return me this data type, the series, which is essentially a collection of 12, 23, 67, 89, 100, right? and the integer type for this column is 64, so int 64, which stands for integers that have 8 bytes. Do you know about bits and bytes? Right? Any one of you does not know about bits and bytes? Sure, everyone knows about it, right? Yeah. So 1 bit is like 0 or 1 number, right? 8 bits is 8 0 or 1 numbers, right? So you have 8 bits, you can have 2 to the power 8, that is 256 combinations. Yeah. So if you have an integer that has 8 bytes, so that is like 64-bit integer, because 8 times 8 64. So that int 64 stands for 64-bit integer. Okay. And what is the importance of having, let's say, a 64-bit integer or 32-bit integer? What is the difference? 64-bit integer can store much larger numbers compared to 32-bit integers, because 64-bit integers have 8 bytes to store them, and 32-bit integers have 32 bytes, sorry, have 4 bytes to store them. Okay. Okay. That being said, you can use these this Pandas library to not only create data frames, but you can also, for instance, you want to write this data frame into a file, you can do that, right? For instance, let's say you had this data frame, this guy, right, and I want to write this data frame as a CSV file. So I can do that. I can say df dot to underscore CSV, and then here I can write the name of the file that I want to store it with. Let's say example CSV file dot CSV, right? This is the name of the file that I want to store it with. And if I run this, it's going to write a CSV file that you can access by clicking this file section over here, right? So this CSV file that just appeared, and you can open this and you can see this is a CSV file. You want to download the file, you can click these 3 dots, you can click download, and this is the CSV file it downloaded, and you can open this CSV file and you see, this is the CSV file. This is the indices, this is the names of the columns, and so on and so forth. And if you want to read about the help for this pandas 2 underscore CSV, so you can read at the read about the help of this, and that can give you access to several options. For example, here, if you do not want these the header, for instance, you do not want the header to show up, right? So what you can do, you have this variable here that you can set to false, right? So this is an argument that you can set to false. So let's say I say here, right, I close this, so I say example CSV file dot CSV, and I say I write the name of the input argument to the function, right, and I say equal to false. This is an argument to the function 2 underscore CSV. Now earlier when we were discussing functions, we wrote the argument in a specific order, right? Like for example, if you had like number 5 and 3, so the first input argument in the function will assume the value 5, and the second input value for the function will assume the value 3, right? There is a separate, or there is an alternative way to specify the input to the function as well, and that separate way is that you can just write the name of the input argument and then say equal to and then the value of the argument. Because if you do not want to worry about the other arguments in the function, just want to change some default arguments. So you just say the name of the variable equal to, or name of the input argument equal to, and then the value. So here in this all sets of arguments, this by default is the first argument. So this is the name of the file, right? And I do not want to change the other defaults. I just want to change this value. In place of header being equal to true, I say header equal to false. So now if I run this, and then if I open this file again, the header is is false now. So I can just download the file, and now if I open the file, the new file is opening up. Yeah, so this is a new file, and you can see the header values which were there in the old file. So these are the header values in the old file, the name, age, and sex. So they are no longer there in this new file. Does that make sense? Clear? So far so good? Any questions? Yeah, okay. So apart from that, there are other options. For example, if I do not want this column to appear, there's an option that I can set for that, right? In place of writing, so the CSV, that stands for comma separated file. So if I just right click this and I open it, let's say in WordPad, right? So it will, okay, fine. I'll just close this, and then I try to open this as well. I open with, let's say I want to choose WordPad to open it. So you see, you have, right, in place of having a CSV or comma separated file, I can replace it with, let's say, whatever I want. Like I can replace with B, C, D, whatever. I can replace it with spaces. I can replace it with tabs, right? So it's up to you. How do you want? I can replace it with double commas, right? And this really helps when you want to have a user defined separator for a file. Now in place of having a CSV file, I can also have, or I can also store it as an Excel file. I want to say df to CSV. In place of this, I say df to EXL, right? So if I run this, it created a problem because of this. So it should work fine, right? Because I changed the what is it called, what are those characters after this dot in the file name, the file type, right? So I changed that to from CSV to XLSX. So this will just write an XLSX file, and if I just want to open this file, I can just download it, and I can just open this. So see, now this is an XLSX file, right? So you can, if you want to save things as XLSX files, you can do that. There are other formats as well which are supported in Pandas, right? Okay. Another example, I have uploaded a file, this housing data.csv on Island, right? This one. So if you can download this file, we can just try to play with this using Pandas. You just download this file. You just click this and make so this file is downloaded. Have all of you downloaded this file, whoever are working on their laptops? Yeah? Okay. So I just go to the place where the files are being downloaded. So this is the download folder. And I can upload this file on Google Colab. So I can just click the file and just drag it, and I drop it over here. It will give me a warning that once I disconnect runtime, or I just exit Google Colab, these files are going to disappear, right? Which is fine, right? You can reload it later on. So you can just drag and drop the file over here, and it's going to upload the file. and you can verify the file is already uploaded. Okay. Just all right. Now, if I want to read the CSV file, I can do that. So I can say, for instance, input housing data, I say equal to PD, which is a pandas, short for pandas, PD dot read underscore CSV, and then I can just write the name of the file, which is housing data dot CSV, and when I run this, it would input the housing data in there. It load the input housing data there, and I want to, for example, let's say get the top 5 lines of the input housing data, right? Because this is a very big file, I want to just see what are the top 5 lines of that. So I can say print this variable input underscore housing underscore data, right? And I say dot head, and I want to ask those top 5 lines, so I just say 5. It will just tell me what the top 5 lines of my housing data. Yeah, so these are the top 5 lines, line number 0, line number 1, 2, 3, 4. If I want to have, let's say, 15 lines, I can just say input housing data dot head 15, so it will give me those 15 lines. Why is it useful? Because that way, you can just get, let's say, top n lines that you want to see, that how does your data look, how does your data look like. Similarly, if you want to get the lines from the end, you can use this dot tail, so this will tell me the bottom 15 lines. So dot head is going to tell me the top 15 lines, or dot head 15 is going to tell me the top 15 lines. Dot tail 15 is going to tell me the bottom 15 lines. If I just print this guy, it will not print everything, right? It will just print the top these lines and the bottom these lines. Then you have these dots, and then you have these bottom these lines. Does that make sense? Yeah. Now, if I want to do something like input housing data dot describe, just describe me these columns. So this is the description of all these columns: count, mean, standard deviation, minimum and maximum, and then you have these 25%, 50%, 75%. What are these? We will see that later, right? This is essentially the description of all these numerical columns. Now, what are these numerical columns? Now, these columns, this crime, for example, is telling you the crime rate, I believe. Let me just double check. Yeah, so this crime is telling you the per capita crime by the town, right? This ZN is the proportion of the residential land zoned for lots over 25,000 square feet, right? So this housing data is basically having some variables, and using those variables, you want to predict what would be the price of the house in that particular neighborhood, right? So at the very end, you have these, the median value of owner occupied homes, right? And this is in thousands of dollars, right? And that is this data set is I think in this from the 70s or the 60s, right? So at those times the houses were a bit cheaper. For example, you could get a $22,000 house in a certain neighborhood in 60s or 70s, right? You cannot get it now in Boston, right? Okay, so then these are the other variables. So you have the per capita crime, the zone, you have the this Indus is yeah, it stands for the portion of area for non-retail businesses, like from industrial zone or something. Then this CHAS is for if it's next to the Charles River or not, right? So in Boston there's a famous river known as Charles River. Depending upon which area of the Charles River is, so that may have a positive or negative impact on the housing, right? Similarly, the crime data may have a positive or a negative impact on the housing prices, right? The more the crimes probably in a neighborhood, probably that would negatively affect the housing prices and so on and so forth. So you have all these variables, right? Then this is, I believe this is the age of the median age of the sorry, the age of the houses, right? How old or how new are the houses, and so on and so forth. And at the very end, you have the median value of the houses in that particular area based upon all these statistics. Yeah. So question is, can you predict the median value of houses in those neighborhoods by given all these statistics? So that is what we try to do in machine learning, right? So there are certain algorithms with which using which we can try to predict. So that is how you can also see what is the relationship, for example, of the median value of the houses to these variables, right? What variables are positively affecting the housing prices, what values are negatively affecting the housing prices, right? You can also get these data, for example, from the Dubai municipality, right? The crime rate was of course going to be like extremely low because this is Dubai, right? It's very safe, right? But you can have things like how old were the houses, were they close to, let's say, are they close to the beach, right? So those kind of variables you can plug in, like what is the population density in a certain neighborhood, right? How many are their businesses, what kind of businesses are there, right? And so on and so forth. So based upon those, for example, you can predict certain areas having higher prices or lower prices, and so on and so forth. Clear? Yeah. So moral of the story: we can use Pandas to load these data frames, or load tabular data, and we can do multiple processes, multiple kinds of processing on that data. Questions till this point? All good? All good? All good? All good. All right. Moving on. So that was a quick introduction to Pandas.